Even if layout and operator skills are improved, further gains will not be achieved without a reliable system for monitoring the operation. Also, we need to provide adequate feedback to the people. Quick detection of problems is critically important for taking corrective action in a timely manner. In this session, we will study the means of providing better monitoring and feedback in our daily operations so that our production system can become autonomously controlled. Jidoka, or automation, is a concept developed in Japan to provide machines with the autonomous capability to use judgment. Without this concept, a machine may move by itself, but it may not be working for you. By using Jidoka, operators can be away or separated from the machine operations, and thus their time can be better utilized. Also, more rapid troubleshooting is possible since problems are discovered on the spot. Making this work, however, requires a great deal of discipline. Whenever a process is disturbed, we need to identify the problem by first stopping production. Then we resolve the problem and finally regain the streamlined flow as quickly as possible. Otherwise, the same problem may haunt us forever. The Jidoka concept applies not only to machine operations but also to line operations. This is accomplished with line stop buttons by the operator, where he or she will push the button to get a supervisor's assistance when a problem arises. This concept is called line stop concept and is a variation of Jidoka. By stopping the line, we expose any problems preventing the production of quality products on time so that we can take corrective action as early as possible. If a line has repetitive problems causing frequent line stops, these will only be fixed by focusing people's efforts. Therefore, we need to develop an effective nervous system in our factory in order to expose the waste and to take corrective action. Jidoka, in its broadest sense, is therefore a concept for exposing problems and taking corrective actions autonomously. To do this effectively, there are several techniques that we can use in developing an effective nervous system. They are Andon, Poka Yoke, and visual control. Andon means lantern in Japanese. Just as a lantern may guide people walking in the dark, an Andon light helps expose abnormal conditions in the factory. In other words, the Andon, or trouble light, will help abnormal conditions become obvious enough to catch people's attention. Buzzers, and in some cases video cameras, also facilitate communication without delay. When factory operations are linked by these means, the factory will function similarly to our reflexive muscle system. Just as our muscles will pull our hand away if we were to touch a hot plate, corrective action should be taken immediately. This Andon board from a Japanese automotive facility is a typical example. As the light goes on, there may also be music coming out of a loudspeaker. This tune may be specific to a line so that people won't be confused if there are several lines in the same neighborhood. The next example is a parts delivery Andon. As parts run low, the operator pushes a button that informs the material handler or tracker of his need. This signal is then displayed at the Andon board, signaling the tracker to deliver the parts requested by the operator. This helps keep communication smooth and line-side inventory low. Parts are delivered only when required, not too early, not too late. Another example of this reflexive muscle system is called Poka Yoke. Poka Yoke is a Japanese word that translates as foolproof or fail-safe mechanism. Poka Yoke helps make the operator's work easier, and at the same time, it eliminates the troubles associated with defects, safety, and mistakes in operation without requiring any undue attention of the operators. There are many different examples of Poka Yoke. This particular example is from Borg Warner. As the U-shaped line was being developed, the employees came up with Poka Yoke so that they could run multiple machines without confusion.
Another problem we encountered was the fact that now an operator had to have more skills. he had to run 3 different kinds of operations rather than just one. And so in doing that, it's easy for an operator to get confused and to load a part backwards and possibly wreck it. And we had that problem on our hobbing machines. And this is the little idler gear that I've shown you, shown here in yellow. And there's a problem with that part. If you load it on the machine backwards, then the teeth are on this side rather than on that side. So when the tool slide comes in on rapid traverse, we would break this cutting tool. And those cutting tools come at about $1,000 a piece. So we came up with the idea to Poka Yoke this so that the operator physically cannot load the machine and start it if he loads it backwards. And all we did was, shown in red here, is a little collar that slips over the arbor, and it has some little projections on it that go over that flange. So if the operator puts the part on backwards, then this flange will stick out in this area, and then the clamping mechanism here on the end will not clamp. So you cannot load the machine backwards and therefore break the tool.
This is an example of Poka Yoke from the welding shop of a Japanese automotive parts manufacturer. Since many welds were required in this assembly operation, sometimes a weld was skipped. This happened a few times a month, causing complaints from the customer. However, an idea was generated to make a gate, and only when all processes were completed would an electrical signal open the gate up. Since this gate wouldn't open if a step was missed, this type of mistake was totally eliminated. This is an example from a compressor assembly line in a Japanese manufacturer, Mitsubishi Electric. In this operation, the operator puts oil into the compressor, but since you can't see from the outside whether oil has been put in or not, mistakes were made. Sometimes too much oil was put in, sometimes none at all. The idea was developed to put in a gate that only opens after the right amount of oil has been put in the compressor. The gate opening notifies the operator that he or she need not be concerned with the oil level. This is an assembly line in the household goods division of the Japanese manufacturer Aisin Seiki. In this line, different parts are used for different models of their product. Since mixed production requires more frequent and faster model changeovers than a conventional line, the people came up with the idea of using a light indicator to distinguish the different models as a reminder for the operators. If we compare these previous examples to this example, where incoming inspection is taking place to check the parts from suppliers, we should understand the benefit of practicing quality at the source. In principle, the people who are providing parts should be responsible for their quality, delivery, and cost for their customers. This provides quick detection and correction of problems, while the other is a very slow process. As these examples of line stop, andon, and Poka Yoke demonstrate, the Jidoka concept can be used to develop an autonomous control system. If we use visual aids to practice this communication and control, we call this visual control. As the need arises and is manifested visually, we take action. However, it requires a great deal of trust and discipline among the people involved for the system to function properly. If we expand this notion of autonomous control, the Jidoka concept may include the display of charts describing the key indexes, production control boards comparing the scheduled production with the actual, posting pictures from around the factory to address housekeeping efforts, improvement boards explaining before and after situations for people to learn how improvements were achieved, and even yellow lines on the floor showing where to store parts can become part of this monitoring and feedback system. As Jidoka and visual control will increase communication, plant newspapers and photos can also help promote better communication.
We try to do different things. We try to make it more like a family, and what we try to do is get good communications between the different shifts and between the different areas that they work. And one of the ways we've been doing this is through this monthly or so newsletter. And in fact, it's called In Focus. what we do is try to get input from the owner-operators as well as the engineers and the manufacturing managers and production control and everybody, just to get little 2 or 3 sentence news items that people might be interested in, when machines are going to get moved, when things are going to be realigned, when there's cost reductions, they found a cheaper way to do this, or part changes, or just a lot of different information. Also, we try to have at least a couple pictures in it each time. It's nothing too professional. We just take Polaroid pictures, copy them on just a plain copier, 2-sided copies, do it on my PC with just a word processing package. It's not fancy, but it works. And it's interesting because sometimes it doesn't seem like everyone is reading it, but last month there was an article in there about we get these needle bearings that we have to tear down when we have to repair units. The needle bearings get grease all over them, and in the past we've kind of been going back and forth trying to figure out whether it's cost effective to wash the grease off or just to throw them out. Finally, an engineer looked into it and came up with a method and found out it was not going to be cost effective. So we said, okay, this is the answer. It's not going to be cost effective. We're not going to do this. Just throw them out. And 2 different people came in to me and said, wait a minute, what process? Was it this or was it this? And so both of those people then talked to the engineer that looked into it and told him about these more cost-effective methods, and we now are washing needle bearings and reusing them. And it's saving money because the people heard about this and it sparked interest. Another thing is we take pictures of just operators working or taking a break or whatever. We try to get all the 3 shifts, and we post these pictures on a board, put them out near the door where you go out, and as the new pictures go up, it's amazing. There's crowds that gather. People really notice when new pictures are up, and they come and they look and they want to see if they're on there or any of their friends are on there, or how they looked in their pictures, or what they're doing, and is their area clean in the pictures, or are we having a housekeeping problem? And it's interesting. Sometimes they take the pictures, but they like it and they look forward to it. And sometimes they write funny captions on the bottom. Nothing negative, just humorous, and people like that.
In effect, these are forms of just-in-time information transfer inside the factory. You might contrast these examples of visual control with using a computer for collecting, processing, and distributing data. Even though the computer has its own important place in manufacturing, those using visual control may be quick to point out that you do not need a computer to tell you whether a box is empty or full. In summary, practicing visual control and jidoka can be compared to the nervous and muscular systems in a human body, which can respond readily to environmental changes. The point is to develop a self-controlled system. As mentioned before, however, accomplishing this requires the involvement of everyone.
I like the analogy of the nervous system and information system, plus the simple means of communication. But does this mean you are against the use of computers?
Not necessarily, but like anything else, if we do not have an adequate ability to use them, we may find them producing or storing a lot of waste.
Aha! So what you are saying is we need housekeeping for the information processing activities as well.
Right. Let's take a look.
We began with an order entry process where the order was called in or faxed in, entered into our mainframe. Mainframe would generate the shipping paper and the documentation necessary to pick material and issue an order to the shop floor for the shop floor to begin the manufacturing process. The overall cycle of that was about 3 to 4 days. It currently takes us 15 minutes or less to do the same process. And we've just shortcutted, in effect, the computer system by having, when the order comes in, a copy of it is delivered directly to manufacturing. Then a parallel activity occurs. Since all the material is available to build a product at the point of use, the actual customer order becomes a document that drives the factory. We've learned many things from this particular experiment. One of the key lessons is a lesson about automation and the impact of computer integrated manufacturing, if you will. In this particular application, we've learned that we had to disconnect the computer system from our process for a period of time and let the process drive what we were doing.
From that, we can step back and really look at what value the computer system can add to the process. Instead of designing a process around the computer system, we're deriving the process system first, or the process of manufacturing first, and we'll automate the information part of that as and when needed.
As this case indicates, if the data collected does not trigger an action on time, such information may have little value, if not a negative value.
Oh, I see.
In fact, just as you have mentioned the housekeeping of information, we can draw an analogy between the office and the factory. Instead of physical inventory in the factory, we have information inventory in the form of paper or data stored in the computer in the office. Instead of material flow, we have information flow. If we think about this, we'll find that the same principle we are studying here will equally apply to order taking, invoicing, and many other information processing activities.
Do you have an example?
Sure. These pictures here show an example of the engineering change process at Sensei. As you see here, this is a one-piece flow layout. The yellow line and well-organized table indicate that good housekeeping and visual control is practiced here. From this simple improvement, the work which used to take 10 days to process is now finished in less than an hour.